Good morning and good afternoon to you all. First of all, I warmly welcome you all to the experience sharing webinar series on water and wastewater management and treatment, which is jointly organized by the National University of Singapore and the Environmental Research Institute NERI together with the JRDC, Joint Research and Demonstration Center for Water Technology, which is under Ministry of Water Supply and University of Peradeniya, Sri Lanka. So this webinar series aims to provide a platform for knowledge and experience sharing in this field between Singapore and Sri Lanka. Under this webinar series, 3 webinars have been successfully completed under 3 different themes. The webinar series 1 was water management and treatment, and the second one was wastewater treatment and management, and the third webinar was on stormwater management. And this webinar will share the experiences and the challenges of industrial wastewater management in Sri Lanka and Singapore, as well as innovations in the techniques and the solutions for more sustainable treatment process. So to begin with, I would like to welcome Dr. Sri Veeragoda to give a welcome note. So Dr. Veeragoda is Director covering up of China-Sri Lanka Joint Research and Demonstration Center, we call it JRDC. And he is also a team leader for Water Safety Plan Advisory Unit in the National Water Supply and Drainage Board, and he has been recognized as an expert in the application of WSP and an auditor in the region by the WHO. So Dr. Veeragoda is a chartered engineer by profession, and he has been involved in water treatment plant design, construction, operation for 20 years. Further, he also served as a visiting lecturer in many national universities in Sri Lanka. His research collaboration expands over Japan, China, Singapore, South Korea, India, Thailand, and UK, Australia, and many other countries. So, Dr. Veeragoda, time is for yours.
Thank you, Mrs. Amil, for a nice introduction. And it's an honor for me to address this forum today. So I am representing the Ministry of Water Supply, Sri Lanka. So we are the recently established institute under the Ministry of Water Supply for taking care about the drinking water supply and managing wastewater. So the China-Sri Lanka Joint Research and Demonstration Center for Water Technology is a gift we got from the government of China. And we are having a partnership with the Chinese Academy of Sciences and University of Peradeniya. When it's coming to Sri Lanka implementation, National Water Supply and Drainage Board is the other partner to us. So this is the series of webinars that we have arranged together with the National University of Singapore. So it's a great honor for me to all the way connect JRDC to NUS and UOP as leading universities in the world. So then we have completed 3 webinars, and here today we are very much focusing about one of the mandate of our ministry, that is the wastewater, how that we are going to address these challenges. So we know that Singapore has done a wonderful job in the world, and they have set many examples for the whole world. So then we are thinking of sharing those experiences, as well as from Sri Lankan side, as well as from the China. We got Professor Anson Way with us, the project coordinator from Chinese Academy of Sciences, so very renowned professor for wastewater treatment, together with our Singapore experts, Professor Hu and all. So I would like to warmly welcome you all the participants around the world, and our presenters, all Professor Oliver and Ms. Asanka, we got Mr. Chintaka, Professor Shamin, and many others. So it's a great honor for me to invite you all. And thank you very much, Mrs. Amil. So the mic is over to you.
Thank you. Thank you, Dr. Veeragoda, for your brief welcome note. With that note, we will move on to the technical session of the day. Today, we will have 3 speakers, and if you have any questions, please type them in the Q&A chat box, mentioning the name of the presenter to whom the question is addressed to. Then we will take up the questions during the panel discussion. So to begin the session with, I would like to welcome Professor Shamin Jinadasa to share his experiences on industrial wastewater management in Sri Lanka, especially the challenges faced in the industrial wastewater sector in the Sri Lankan context. So Professor Shamin is a research-oriented environmental profession. He is attached to Department of Civil Engineering, University of Peradeniya, and he is also a Pi Fellow under Chinese Academy of Sciences. He has more than 20 years of water and wastewater-related design experiences, of which 10 years were in the academic and research and consultancy. He had considerable exposure supporting research and development programs both regionally and globally, and he possesses thorough knowledge of environmental engineering design and consultancy. Majority of his experiences in multinational institutes in multicultural environments, working across different cultures, languages, and time zones. He have a good track record of initiating projects, preparing project proposals, coordinating and running the projects, and also implementing projects. Past projects have revealed the potential and capacity for the translation of R&D to reveal world problems. So, Professor Shamin, the time is for yours.
Thank you, Ms. Samil. Hope you can hear me. And see the slides. Ms.
Yes,
Samil?
we can hear you and we can see the slides.
Sure, thanks. So again, I would like to thank all the organizers for inviting me, and also especially the jointly organized this program by the NUS Environmental Research Institute and Joint Research and Demonstration Center with the Ministry of Water Supply, and also the participants from the Chinese Academy, Professor Yung Song Wei, and the Board of Investment in Sri Lanka, Mr. Chintakar, and Mr. Asanka. Thank you very much for joining us today. So I would like to brief you on the industrial wastewater management in Sri Lanka, some of the challenges which we have the experience, which I would like to share with you. And also I'm currently from the University of Peradeniya and a Pi Research Fellow. And this currently I am working under this fellowship in collaboration with the RC's Chinese Academy of Science. I'm working with as a joint project with Professor Yung Song Wei. Recently there were many concerns on this industrial wastewater management, and also this focus actually came from the what are the pollution, how it happened in our water sources. There are several incidents like recent past in the Kalin River, where the major river water basin in Sri Lanka, one of the major river in Sri Lanka, and also some of the incidents like happened in maybe there is called Ratu Paswala incident, and Jaffna there was a oil issue. So most of them are related to some of the industries and the major concern on the environment, and we have to protect the environment. But it's the same time we are moving with the industry and we are going with economic development. So we have to have manage our environment, but also we have to go with the development by having a very good mechanism for the industry and industrial waste management. So what is industrial wastewater? Actually, I'm not going to take much time on detailing or explaining these aspects, because I know that many of you are thorough with these concepts. But before that, I'll just take you of some introductions, so that this wastewater may be coming out from the industrial processes, and like even animal operations, especially all the dairies, and even called as agro industries. So this wastewater sometimes we consider as stormwater or the leachate, and sometimes the sewage may also a part of this, but not the major component of this industrial wastewater. So when you see the treatment plant concept, I'm taking to take the laser pointer, so that when you have the industries, sometimes we have to understand the major concept that we may have a centralized treatment plant where the industries are located in industrial park or industrial zone, so that all their industrial wastewaters are connected to a one treatment plant. So that these wastewater mostly cannot be discharged directly to the centralized plant. It has to go through some kind of pre-treatment before it comes to the major one, the centralized treatment plant. So that the Central Environmental Authority in Sri Lanka or other environmental authorities in other countries, they have the agreement and provide the EPL, we call Environment Protection Licensing, to the industry once they have or following all these necessary precautions and the guidelines given by. And but some of the cases, the industries or the locations or zones, they may not having this kind of centralized plant, so they will have their own treatment plant, which includes the main treatment as well as the pre-treatment component. So actually, I think most of you know the basic concept of the conventional wastewater treatment, where we have the screening, grit removal, and the primary clarifiers, and the biological treatment can be have the activated sludge, or some kind of anaerobic systems, the membrane technologies, and clarifiers and the chlorination. So there is number 7. You can see one of the important aspects that where we have a monitoring aspect, where we before we discharge our the treated water into the environment, where it has one of the major concern before we discharge. And also the sludge has to be managed properly, collected at these treatment plants. There's another component in the conventional treatment plant. So what are the major challenges when it comes to this industrial wastewater related in Sri Lankan context? I'm trying to go through on these aspects actually, the characteristics of our industrial wastewaters, what are the discharge standards, how they are going to be sometimes challenges, and how to develop the appropriate technologies, the sludge generated from our industries, how to manage it, the resource recovery options, how much concern of the energy usage of the treatment plants, the capacity building of the staff on the wastewater treatment and on our engineers, the accredited laboratories with the availability, and the cost, like the investment cost for the installation, and also even the operation and maintenance. So I'll go through some of the aspects. Actually, we have today joined with from the Board of Investment in Sri Lanka, and the Chinese Academy of Sciences, and Singapore the professor. So I'm sure during the discussion we can bring more aspects. So when it comes to the characteristics, actually there are a few things that we may consider, that especially which is different from the domestic wastewater, why that we are worried, or why we have given special consideration. So the biodegradability is one of the important aspects on the industrial wastewaters. That's because if you won't have a successful biotreatment, requires a degradable organics and relative absence of this inhibition or inhibitory materials. So that the COD to BOD ratio could be a major component to see with how its biodegradability. And if the CO normally, like we call, if the COD to BOD ratio is less than 3 to 1, it will be easily biodegradable. Likewise, if this value is going high, it will be difficult to treat this the wastewater. Strength wise, there are different industries, they have different strength or the concentrations, how they are going to affect. Volumes, again, these volumes sometimes will change, but to what extent these industries produce this wastewater, the variations, there will be some fluctuations in the wastewater generation, how we can handle these conditions, and the special characteristics. Sometimes the operational changes can affect this the wastewater treatment plant on the content. So one of the major concern on this industrial wastewater is the inhibitory substances where these materials could harmful to the biological treatment or the bacteria. So, for example, the coconut industry in Sri Lanka, they have this oil content around 4,000 milligrams per liter. For example, actually, usually what we consider the heavy metals, ammonia, the sulfur, oil and grease, or other hazardous substances which we consider as inhibitory substances. These concentrations have to be lowered or minimum before it comes to our centralized treatment plant, or we call biological treatment plant. So that like sometimes these conventional models like oil traps for the removal of oils may not work. For example, we have worked with the bakery, or we call the restaurants, and also the desiccated coconut industry. So it's very difficult to handle these kind of oil contents, and also ammonia and sulfur content from the rubber industry. So without a proper pre-treatment, will be very difficult. So the pre-treatment is very important, and we have to have a proper mechanism to handle this kind of the compounds. So especially what we call the inhibitory compounds. So that, as I mentioned, some that pH adjustment, the coagulation or the chemical addition by some methods could be option for the as a pre-treatment methods, and also the adsorption, precipitation, and also the, as I mentioned, chemical aided dissolved air flotation kind of those options would be more better pre-treatment options when it comes to the industrial wastewater in general. Strength wise, as I mentioned, the different industries have different like strengths, like coconut industry, paper. So it varies like thousands of BOD, sometimes 10,000s of BOD, even more than that. So that how we can handle these concentrations and the strength or the loading conditions. And when it comes to the centralized treatment plants, it's very important that we maintain the level of concentrations or the strength, the limitations that is given by the centralized treatment plant. When it comes to other challenge we have is the volumes or varying conditions. Actually, recently, as all of you know, that due to COVID and other conditions, sometimes we had to lock down. We had these lockdown conditions, and sometimes long holidays. So how we can handle these varying conditions with the volumes, and also usually we have this peak and average conditions. So how we handle these kind of conditions with our treatment plants, so that especially we should able to handle. Sometimes there will be some plants maybe no operation or less operation, like sometimes holidays and other aspects. So that during those periods, how we can handle our treatment plants, that would be a major other challenge, because the biological systems, they have to run continuously, and if there's any disturbance, or we call the enough supplement of the food, or the wastewater is not sufficient, there will be some so this is one of the aspects that we consider in this fluctuating conditions, that as option the sequencing batch reactor conditions, that where you can handle the fluctuating the flow conditions, where you can have the different number of cycles per day when you have less amount of wastewater generated. So the full in the so the important aspect is a kind of compact treatment. Also, there's advantage of the having a large load bandwidth. So these are the some of the options that we may consider on the this kind of fluctuating conditions. When it comes to discharge standards, for the Sri Lankan context, some time back it was like industry specific standards. Now some of changes happening recently. So whether we are going for the industry specific standards or these common discharge standards. And also we have some the challenges with the testing of these standards, because sometimes we do the testing for the main or general parameters, but detailed analysis maybe not conducted frequently. We need to have kind of facilities. So this conventional or the routine measurements would be BOD, COD, the solids, pH, or like oil and grease, like that, but need a detailed analysis frequently, for especially for the industries, to monitor the effluent water quality, maybe before pre-treatment, after pre-treatment, or during the centralized treatment plant. Another aspect that we need to consider is the appropriate technology which suits to our conditions, so that especially the where we can consider this anaerobic process precedes the aerobic process, where we can reduce the energy requirement. So when it comes to the anaerobic concept, still it is not much practiced or popular kind of Sri Lankan context. So there is a room for us to develop this kind of systems, and also the membrane bioreactors are very much applied in the industry now. So there is a possibility, but still we are lack of the expertise to some extent. So, and also the nature-based systems incorporating this incorporating these unit processes. So there are the different processes like the membranes bioreactors and other wetlands aspects. So how we can incorporate these different systems, and possible upgrade of the current systems rather than going for a new treatment plants, whether we can have change our current anaerobic filters or anaerobic systems to the anaerobic membrane bio, so that and also we are very much going towards the cleaner production, where we can think about the less water usage. So this is the actually at the source itself where we can reduce the amount of wastewater generated. So as of all of you know that, as I mentioned, we always prefer, although we prefer for the anaerobic system, still we are going with the aerobic system, which is popular, where it is generating more sludge and energy consuming. But when it comes to the anaerobic system, as you know, it generates the more like useful energy product like methane, and also the less sludge. So still they have room for the development here for the so when it comes to the resource recovery, we are heading towards circular economy. In this context, water, sludge, and other resources that we can recover from the treatment plants will be very important Sri Lankan context. So still we have some challenges to what extent we can recover the water, and especially even the water availability, and the National Water Supply Drainage Board and other is very much keen on the thinking on how we can cater the required amount of water for the industry, because the water availability is limited, and still we have, I mean, in the future it will be more and more, so that how we can manage these water aspects and the sludge and the resources. So as I mentioned, it's like, although we call wastewater, it's water because still there's a possibility that we can reuse the water, and because the water demand is increasing and we are very much challenged with the water availability. So we need to go towards the water efficient systems and resource efficient cleaner production systems, so that we can recover more water from the wastewater, and because still we are sometimes some industries totally depend on the groundwater in certain areas in Sri Lanka. And towards we are again with the zero liquid discharge concept, that where we can recover more water and solids and have a more the resource recovery system for the industry. And one of the major, I think this is a very difficult the situation at some of the industries, where they don't have much enough facilities to handle their sludge generated at their the plants. So it's like there's not much disposal options available, and only we have only one plant in Sri Lanka where we have kind of incineration, and where there is a possibility to have the resource recovery and options where we can go with this sludge. Sometimes whether we can reuse this sludge or kind of resource recover the options can be used for the construction aspects. So still there's a room for development, but mostly we have to consider this may contain the hazardous substances where we are generated from the industries. So there's a big room for us to develop this one, and certainly one of the major challenges we found during the discussions what we have noted. And other is that towards this our digitalization and the how to have the energy optimized systems, so that we are moving towards, I think, this automatic dose control systems where and also intermittent aeration systems, that we can reduce the energy consumption and this aerated plants or aeration systems, and especially the sensors where you can control the dissolved oxygen or the other pH in the chemical dosing, so that we can see how we can incorporate this technology into our treatment plants, like IoT based smart treatment plants, and also high efficient equipments, and also especially, as I mentioned earlier, the anaerobic digestion in place of aerobic digestion, how we can incorporate. So this is where we have some kind of challenges, but we are moving towards on this aspect. And one of the other aspects actually is the capacity building and accredited laboratories, so that we may need more staff to go and see how the industries are performing on this industrial, basically what we call do the inspections, and also the establishment of laboratory facilities, like sometimes not only for the wastewater, even for the other aspects like the noise and dust, and this accreditation scheme for these laboratories. And also we need to update the staff about the plant operation, maintenance, and also especially the energy efficient systems, so how we can move towards energy efficient systems, and also especially even the emergency situations, how you can handle that kind of situations. So this would be my last slide before ending my presentation. So as we considering this water and the industrial wastewater with all this economic development, what do you think this industrial wastewater treatment and wastewater treatment, where we consider is already always connected to all the sustainable development goals which we are targeting on, especially I'm sure the BUI here, they would share the experience, what are their plans, and how we can get together to achieve this kind of target that we are thinking for the future, because this clean water sanitation again connect to the climate action, the affordable and clean energy, the industrial innovation and infrastructure, sustainable cities and the communities, zero hunger. So it's connected almost to everything. So as that's what we have put here, the 6 sustainable development goal number 6 in between, in the center. So thinking on that, as while we have these challenges and we are moving towards for this technology, and also with the not only with the technology but also consider the economic and social aspects, having a sustainable systems for industrial waste management for the future. So this is what I would like to thank again for giving me the opportunity, and I'm sure that we can discuss more details during the discussion, and thank you again.
Thank you, Professor, for your elaborative and informative presentation. So next, we will have an interesting presentation on industrial wastewater management in Singapore. So that will be on techniques and solutions in Singapore context. That will be done by Associate Professor Oliver Patrick. And Professor Oliver Patrick is from NERI and Center for Water Research Department and Department of Civil and Environmental Engineering, National University of Singapore. His research work is in electrochemical technologies and advanced oxidation process for industrial wastewater treatment and reuse. He is also an adjunct professor at Research Institute of Mineral Environment of University of Quebec. Professor Oliver is an editor for Water Science and Technology and an IWA Fellow, administrator, newsletter editor, and webmaster for Specialist Group on Water Reuse within the International Water Association. An economic engineer by formation, Professor Oliver obtained his PhD from Supagro Montpellier, France in 2005 on a collaborative work between French National Research Institute of Agriculture Research and Anna University, Chennai, India. So, Professor Oliver, time is yours.
All right. I hope that everyone can hear me. Thank you for the intro. Thank you for the introduction. My name is Olivier Lefebvre, not Patrick. Patrick is my second name, but I don't use it. So you can call me Olivier. And so I'm here to talk to you today about the industrial wastewater in the context of Singapore. So I will be focusing on techniques and solutions, but before that, since this is the before that, I would like to expose the very specific way that Singapore deals with water. So I want to start by showing pictures of the university and US for those of you who may not have gone there. So what you're seeing here is an image, I would say, an image of modernity and a lot of greenery. And Singapore is a very interesting city that has evolved very fast and that is evolving very fast into becoming one of the probably most livable cities in the world, but it wasn't always the case. And so here I'm showing you photos from the past. And so what you're seeing is that back in the days, it wasn't like so easy in Singapore to deal with wastewater. And I think that everybody can easily guess what is carried out in these buckets. And I was very surprised when I was told that this system was still ongoing, at least at a residual level, until the early 1990s. So it means that really this shows you how fast Singapore has grown from being an emerging economy or a developing country, as we called them back then, into being now one of the very advanced city. And when talking about the topic of water, a global hydro hub that is worldwide famous for new water, which is water that has been used and that we reuse and that we turned into highly purified water by using a combination of membranes and advanced processes. And when you think of Singapore, it may not be so obvious, but because you will see a lot of water. But I really want to bring to the attention that that if you look at the water capability per capita, our water capability is equivalent to some of the Middle East countries with less than 110 cubic meter per capita. That's why there is such an important need for reusing water in Singapore. So it's not that we don't get water, we are right on the equator, so it rains a lot, it rains almost every day. The problem is with storage, and the problem is with high capacity, high density of population and the decisions on what to do with space. And sometimes water is not the highest priority. There are other ways that can make more money in using space than water. So very water scarce, which is the reason why we have our 4 national taps. Let me zoom that in. Our 4 national taps, which are imported water that we get from Malaysia. Then we have our water from the local catchments, as I showed you in the slide before. You could see our beautiful Marina reservoir next to our CBD. We do a little bit of desalination, and then of course we have this new water that is water treated by membranes. Here are some examples of water being integrated into the city in Singapore. You can see the Marina reservoir, for example, with our famous Marina barrage over there, for which the goal of which is to separate the fresh water inside from the seawater outside. So originally, this marina was salt water, but now it's being turned into a reservoir that can be used to provide more drinking water. And then we have this ABC, Active Beautiful Clean Water program, that also intends to bring the water everywhere into the city and integrate it and incorporate it in order to improve the livability of the city. So the new water has been a success story for several reasons that maybe can be an inspiration for how an inspiration for many countries on how to implement water and water reuse nicely. First of all, the new water here is seen as a seal of quality. That means it's not something like they say, for example, in the US or in Australia, they tend to call it sometimes they brand it as they call it a toilet to tap or this kind of thing, which obviously doesn't make anyone want to adhere to it. So I think that here in Singapore, new water is really seen as something positive. Most of it is used for the industry, but some of it is even bottled in order to really show that it's not something to be ashamed of. It adheres to the WHO guidelines for drinking water. It's actually too purified to be so good for the body because it needs to be remineralized. But so this really shows that there is a trust in the technology, trust in experts, trust in governments, which has also been supported by a positive discourse from the media. Finally, I think that one of the ways to sell water reuse to the people, to the community, is to develop a thick narrative that really shows why it's necessary to reuse water for a number of reasons, especially in the context of climate change. There is the context of sustainability, strategic security reasons. For example, in our case, in Singapore, I was showing you that we still import water from Malaysia, and I don't think any country likes to be dependent from any other country for something as essential as water. So nowadays, water reuse already provides in average 30% of the nation's water demand, and these numbers are expected to they keep increasing. So we rely more and more on this new water. So here are more examples about new water before I move on to the specific topic of industrial wastewater. So first of all, I want to show the new water visitor center, again, part of an overall marketing strategy on how to brand new water, how to brand water reuse with a positive image instead of a negative image. And I'm even showing you the new brew, which is one of the newer initiatives from the Public Utility Board to partner with some beer companies in order to make some beer that makes use of this new water. So now, moving on to the challenges ahead, I want to talk about the evolution of water usages. So already in Singapore, in Singapore, I would categorize the water usages between residential, commercial, institutional, and then probably industrial wastewater. We have very little agriculture. We do have a little bit, but it can be neglected here. So industrial wastewater, as you see, is already represents a large amount. So not all of this industrial wastewater is processed water. A lot of it is for cooling towers, etc. But so you see that the share of the industrial water usage continues to increase in Singapore. And so if you take into account that there is a need for more water, and at the same time there is a need to increase water reuse, to increase the share of new water that we make, then it means that increasingly there is a need to also learn to purify industrial water better in order to be able to reach that quality of water that is compatible with new water production. And those two different waters are very different in the sense that it's not at all the same quality of water. You see a residential, the usual water, the water that we flush, the kitchen water, etc. All these are quite easy compounds to to degrade. So it means they can be fed to bacteria, they can be fed, they can be just sent to normal wastewater treatment plants, such as the speaker before me was mentioning, where the activated sludge, which consists of bacteria, will be able to degrade and purify this water. However, with industrial water, when we're talking about process, depending on the processes, and in Singapore, we have a lot of electronics, pharmaceutical, chemical industries, then you get very complicated compounds to degrade. And those are not biodegradable. Those are not things that you can send straight away into a wastewater treatment plant, because a biological treatment plant will not be able to absorb and to degrade. And in some cases, they are toxic. And in some cases, they will just kill those bacteria. So really, it shows that there is a need for different types of technology in order to be able to deal with those industrial wastewater. And Prof. Hu and myself, we actually work on different techniques that are able to deal with those recalcitrant organics, and that we call the advanced oxidation processes that are based on the hydroxyl radical, which is one of the strongest oxidant. It's very strong. It's very good at breaking down those double bonds and those aromatic molecules, and it can even go all the way to mineralization. That means conversion into CO2 and water. If you want to push the dose so far, which is not necessarily what I advocate, and this is what I will show you later. So in my group, what the technology that I want to introduce in this talk, because this is the one that my group is more famous for, because this is the technique that we have been publishing the most on, is called electrophanton. So you may be familiar with the Fenton's reaction. And the Fenton's reaction is the reaction between ferrous ion and hydrogen peroxide H2O2 in order to generate those hydroxyl radicals. So electrophanton is the Fenton consists of the Fenton's reaction, but where the Fenton's reactions is triggered in an electrochemical system. So that means it's all triggered by a power supply, which limits the needs for addition of reagents, which simplifies the logistics, especially when some of those reagents like H2O2 can be very difficult to procure because they are explosive precursors and require some very difficult parts. So electrophanton is great because instead of introducing H2O2 into the system, we can actually generate H2O2 in situ. And how does it work? Well, it simply works because this system, as you see, has a positive anode and a negative cathode. And so what happens is that if we aerate and we put oxygen into the system, then oxygen will get reduced at the cathode. And if we apply the right potential, then we can trigger an oxygen reduction, not to water, but with a 2-electron pathway, we can trigger the reaction to H2O2. So it means that we just need to bubble oxygen or air. We need to bubble air, and then we directly generate H2O2, which is one of the components of the Fenton's reaction. The other component of the Fenton's reaction is Fe2+. So you see that when you add in Fe2+ and H2O2, then what you're seeing here in blue on this slide is the Fenton's reaction that generate those hydroxyl radicals. Now the chemical Fenton reaction works the same way, except that you just add in H2O2 as a reagent into your solution with the limitations that I explained before. But the Fenton's reaction has another disadvantage. Is then what do you do with this Fe3+? That is there. Well, in a normal chemical Fenton process, this Fe3+ will just accumulate in the solution. So it means that you need to keep adding on more Fe2+. And then the other negative aspect is that when your reaction is finished, one thing maybe that I should have that I could have mentioned before is the solubility. So this Fe2+ and Fe3+ will also react, but is only soluble in acidic pH. So this reaction takes place at pH 3. Of course, when your reaction is finished, you want to raise the pH closer to 7. Once you raise the pH to 7, then this Fe3+ will not be soluble, and you will start forming a lot of ferric sludge. So with electrophanton, how do we deal with this process? Electrophantom has the advantage, as the other advantage, that this Fe3+ also gets reduced at the cathode. And by reducing this Fe3+ at the cathode, it gets turned back into Fe2+. So it means that it provides the advantage of doing the regeneration of Fe2 with two advantages. The first one, you don't need to have so much Fe2+. Well, actually, we can work in catalytic quantities of Fe2+. So one advantage, you use less. And also because there is less ion into the solution, in the end, when you raise the pH to 7 at the end of your experiment, then you don't get so much sludge. You get very little sludge, almost negligible in this system. So you can see that the advantage of the electrophantom reaction then compared to the phantom reactions are double. Less reagents are used, like H2O2, less like no H2O2, and very little Fe2+, less cause because less ferrics, because less sludge to dispose at the end, or virtually no sludge, I would say, in practice a little bit, but very little. And also ease of operation, because from an industrial operator, it means that they don't need to think too much about how much H2O2 they need to add, etc. Basically, it's just it's a plug and play. You just need to press the button to turn on the power supply, adjust the potential to the value that you want it to be, and then your system works. Once you have those hydroxyl radicals, then it's the same as any other advanced oxidation process, where it will attack all those recalcitrant compounds and it will break them down. And then it's up to you to decide how much you want to push the system. The more you push the system, the more expensive, obviously, your treatment, because it takes longer. But if your goal is to reach full mineralization, you can achieve that. Nevertheless, this is not necessarily what I advocate. So here I'm showing you a little bit like the way that I'm envisioning this system. So you see, you can have different industries with different types of compounds. And typically, at least in Singapore, they would need to release their water in the overall sewerage system, where then it's sent to a centralized wastewater treatment plant, a little bit like what was said before. So now what they could do, and the way that I see it, because those electrochemical systems are very practical, they're modular systems, they're quite small, then the way that I see them, they can be used, you can just put a small dose. You can check with a toxicity sensor, for example, with an optic sensor, you can check that the toxicity level decreases. And then after that, you can pass it to a biological treatment, because biological treatment is cheaper overall. So that's why I was saying, you don't need to go necessarily to full mineralization. As far as I see it, I think we just need to break down those refractory molecule, and we just need to ensure that we don't add any toxicity and that we actually reduce the toxicity if needed. And then after that, I believe that we can have a system that is sustainable, where then the treatment can be finished by the centralized wastewater treatment plant and can be turned into new water. So again, to continue to talk a bit more about what the practical experience that we have had with this. So it's a system that we have validated with a number of wastewater, electronics, pharmaceutical, or one that I like to show because it's very visual, is the treatment of sludge, from example, from a chicken farm in Singapore. So you see here, we have combinations of treatment, such as electrocoagulation. You see that it helps precipitate the solids, and then we are able to further clean the supernatant in an overall system that takes 2 hours of electrocoagulation, 4 hours of electrophantom. So after 6 hours, we can go from this gross material that you see at the beginning until water that is quite clean. We do a lot of focus on scale-up systems. So here I'm just showing you some examples, including one pilot that we recently started working on. So you can see the battery of anodes and cathodes and the way that they are working. And yeah, I think with this, I just want to conclude by showing you in Singapore. So you see Singapore, we already have 2 big wastewater treatment plants, with the third one that's about to open. That's the one that has the dashed line. We have some desalination. Some of them are already. I think the one in anyway, I forgot the name of that desalination plant. I think we have 4 that are open and the 5th one that is about to open. Singapore has a specificity that most of the city is in the south, whereas the industry are mostly in the west. So, and this is where I see my electrophantom system being able to deserve all those industries, and so combining nicely and integrating into an overall system. We also have a few industries in the east, even though they are fewer in quantities. And with this, I will stop here. If you want to connect with me, I give you here a lot of different ways that you can connect with my group via Facebook, via Instagram, or via Twitter. And I also have a blog. And thank you very much for your attention. Yeah, I will stop here.
Thank you.
Nice.
Thank you, Professor Oliver, for your comprehensive presentation.
Yes.
Moving on with the schedule, our next speaker is Mr. Ishanka Vimalavira. He will share his experience based on a case study of industrial wastewater management in Sri Lanka. Mr. Ishanka is a PhD candidate at Chinese Academy of Sciences and a senior technical manager in the industry. He is a senior technical manager at environmental engineering consultancy firm in Sri Lanka, known as CTEC. With almost a decade of industrial experience, Mr. Ishanka focuses on developing innovative solutions to the industrial waste challenges faced in the community today. He is an associate member of several professional bodies and is highly regarded in the field of environmental engineering. He serves as the chairman of the Young Water Professional chapter of IWA in Sri Lanka. Currently, he is carrying out his research on rubber industry wastewater treatment for his PhD study. Mr. Shankar, it's time for you.
Okay, good afternoon all. Thank you, Engineer Samuel, for the nice introduction. So let me go through my slides. Today I will be discussing on my PhD research work, which we have done industry-related wastewater management process in Sri Lanka, the natural rubber industry. So I'll be discussing on the introduction of the process, introduction of the sector, and the problem identification, and what is the proposed solutions which we have proposed, and the results and discussion, and the conclusion which we have got through the so far from the research work. So when we consider the export landscape of Sri Lanka, we have done around 13.4 billion of USD worth of exports in 2020, and out of that one, basically the service sector and the apparel sector, agricultural sector, and the chemical sectors were the main players of the export industry. And out of that one, when we consider the chemical industries, 1.7 billion of USD dollar was contributed in the 2020, and out of that one, rubber industry or the rubber related products were the main player in the chemical sector. So rubber industry is one of the major industries which is very vital for Sri Lankan economy. And if you consider the rubber industry itself, mainly we are processing 4 different products in the rubber industry. Basically, centrifuge lattice, creep rubber, smoke sheets, and TSR, technically specified rubber. So these are the main 4 production processes which we normally observe in the rubber industry in Sri Lanka. And out of these 4, the centrifuge latex is the main pollutant generating industry out of these 4. If we look into more detail into the centrifuge lattice production process, from the field collection point up to the final end product, there's been numerous amount of energy and the chemicals has been added into this process. And the main physical process in the centrifugal latex industry is the centrifugation. So from the raw latex, after adding certain chemicals, centrifugation is the main activity. Then we have collect the concentrated latex, and whatever the remaining part, which we call as serum water, goes out from the system. Then the further serum water being further processed, and finally they are producing skim creep rubber as well. So when we are considering this total system, the main effluent, discharge from the this process is the wastewater. So at different locations, different strength of wastewater being discharged into the effluent treatment plant. So normally this rubber has been processed in medium and large scale factories in Sri Lanka, especially the centrifugal latex rubber. So normally after the treatment, after the mild treatment after mild treatment, this has been discharged into a nearest stream. And mostly these rubber cultivations are in the dry zone of Sri Lanka, and in the dry season, much of the dilution water is less in the natural stream, so that anaerobic condition or the septic condition produced, and it has degraded the surface water quality. So Sri Lanka Authority, especially the Central Environment Authority and the Board of Investment as well, has looked into this matter, and they have strictly regulated these rubber wastewater discharges into the natural stream, so that recently also they have strict the industry further. Strict the regulations further. So with that one, now the almost all these rubber industry, especially the centrifugal latex factories, are struggling to meet the discharge quality standard. So that is an ongoing technical problem which we rubber industry faces in Sri Lanka. So before proposing proposing a suitable technique into this issue, we have characterized the rubber wastewater. So what we have observed is the serum water, which mainly consists of protein and amino acids, carbohydrate, and inorganic salts. And also, other than that, it contains smaller particles and uncoagulated and traces of these processed chemicals. So due to these chemicals and the serum water, we are observing very high amount of COD value, BOD, and the pH is acidic, which is relatively low. Then high amount of ammonia, sulfate. So these are the main constituents or the pollutants in the rubber wastewater. So when we proposing a solution, first we have done the pre-treatment. So pre-treatment being done as the lime magnetic seed coagulation. So we have used the lime for the pH adjustment. Then the chemical coagulant PaCl and polymer addition was done, and the magnetic seed was added to reduce the settling time. So the pre-treatment sequence was this lime magnetic seed coagulation. Then that one we have introduced the biological system secondary treatment. So we have developed three basic reactors: anaerobic, anoxic, and aerobic reactor. So in the anaerobic reactor, we have targeted the sulfate reduction, and the anoxic one, the denitrification, and in the aerobic one, the nitrification. So we have fabricated the laboratory scale setup. So here, this is the schematic of the laboratory setup. So first we had the anaerobic reactor, then the external ceramic tubular membrane was utilized. This is the ultrafiltration level filtration unit. Then the anoxic and oxic reactor was been introduced, and at the end of the aerobic reactor, we have a submerged ceramic ultrafiltration membrane. So from that one, we got the final discharge. So this is the basic reactor setup we utilize for the biological treatment. So this is the actual photographs of the reactor setup. Then let me go through the the key parameters of the process. So when it's come to the COD, we have been able to achieve the COD removal efficiency around 90%, which cater the anaerobic process of 41, anoxic 35, and oxy process of 40. They have contributed for the overall COD removal. Then the ammonical nitrogen, also the ammonical nitrogen was the main form of nitrogen in the rubber wastewater. So that has been also reduced by 84%. Then the other pollutants like the sulfate and phosphate removal was 92%, and sulfate has been also been reduced by the process. So if we go through the metabolism of the treatment process, the anaerobic process, we have observed the sulfate has been reduced by the use of organic carbon anaerobic reactor. Then at the anoxic reactor, the sulfite has been further act as the electron donor for the denitrification process. So sulfite has reduced to sulfur, then the nitrate and nitrite has been reduced to nitrogen gas. And mainly in the aerobic process, the ammonification has been observed. So then finally the mass balance of the this total process. So anaerobic process, we have observed around 41% of COD removal and anoxic 14, and COD oxic reactor, we have observed around 36% of COD removal. Then basically the ammonical nitrogen been reduced mainly at the oxic reactor, and phosphate has been mainly reduced in the anaerobic reactor. So these are the mass balances which we have observed in the biological process. So let me go into the final conclusion. So we have treated this pre-treated rubber wastewater. We have introduced into our membrane setup or membrane bioreactor setup. So we have observed, or we have done the sulfur-driven autotrophic denitrification process as the key process for the ammonical nitrogen removal, as well as the sulfate reduction as well. So removal efficiencies, we have gained COD around 89%, ammonical nitrogen 84%, sulfate 30%, and phosphate nitrogen 92%. And so this is the conclusion. And I would like to acknowledge Professor Yang Song Wei, who is a panelist in this discussion as well, and Professor Shamin Janadasa and Dr. S.K. Veragoda for the support they have given. And this research was funded by the Chinese Academy of Sciences and Research Center for Eco-Environment Sciences and China-Sri Lanka Joint Research for Water Technology in Peradeniya as well. So thank you very much.
Thank you, Mr. Shankar. With that presentation, it's time to conclude the presentation session of this webinar. We had 3 very informative and excellent presentations. Now we will move on to the panel discussion. So the panel discussion and QA session will be moderated by Professor Jiang Yong Hu. She is the Deputy Director, NERI, and Director, Center for Water Research, Department of Civil and Environmental Engineering, National University of Singapore. Professor Hu specializes in the field of water treatment and water reclamation. She has published about 170 papers in various international journals and acted as chair, co-president for various international conferences. She serves as editor, associate editor, guest editor, and editorial board members for various journals. She served as IWA Governing Assembly Singapore representative and IWA Aspire Council member. She is currently the president of Environmental Engineering Society of Singapore, WESS, chair of IWA Specialist Group on Assessment and Control of Hazardous Substances in Water, and International Ultraviolet Association board member. She is a fellow member of IWA and Institute of Engineers, Singapore. She is also a recipient of Prosper.net Scopus Asian Pacific Young Scientist Award in 2009, and Best Environmental Practice Green Apple Award in 2016. Professor Ho will continue with the proceeding from here on. Thank you.
Thank you, Zamil, for a very nice introduction about myself. Good afternoon to all the participants of today's webinar. And we are now having our panel discussion and Q&A session. And I'm the moderator for this session. And with me, we have a number of the panel members, and they are turning on their camera. So I'm going to introduce each of them, and they also can actually introduce themselves because I don't have the full details. And just now you have already heard our three speakers talk, and we have Associate Professor Olivia with us as a panel member, and we have Professor Xiaoming with us as a panel member. And on top of they two, and we have Professor Yong Su Wei from Chinese Academy of Science. He's a director of Laboratory of Water Pollution and Control Technology. Maybe I would like to invite Professor Wei say a few words to introduce yourself. And before I introduce another panel member. Professor Wei, please. You are muted. Professor Wei, you are muted.
Okay. Yeah, sorry. So many thanks, Professor Zhang Yonghu, as an introduction. So first, I would like to thank Professor Xiaoming and Dr. Wala and all of you that invite me to join the webinar series, Industrial Wastewater Treatment. So firstly, I would like to introduce myself. And currently, my research area focuses on the water pollution control for region and watershed. So, and many focus on the wastewater treatment and the use, and especially use such kind of biological technologies, and also the membrane technology, and also do some watershed restoration like the river and the lake and the reservoir. And also do some research focused on the organic solid waste treatment and disposal, like the sewage sludge, animal manure, and municipal solid waste, and especially we use the composting and digestion. And I also do some research related to the antibiotic resistant pollution in environment. So for this I think antibiotics pollution control is also very important. Now that is one health, so and animal, human, and the environment. So that is a very good concept for this. So and anyway, so I'm very happy to join this. So for the industrial wastewater, it's also a big challenge in China, and as we know, so in China the industry provides a huge driving force for China development, and there are lots of industrial park, and for the development there are also lots of industries like the chemical engineering and pharmaceuticals, and also lots of such kind of industrial wastewater is also a big challenge. I think so we can share such kind of the experience and learn each other from each other. So and we also can share experience. So and that is very good. The chance to know each other, and I hope in the future, and we can meet each other face to face in the future, because China is now open. So and Professor Xiaoming also at the Pi 5 Fellowship of Chinese Academy of Science, and he will visit Beijing roughly in May. And Dr. Wala Goda also will visit our country in March. So and so there are lots of chances we can to discuss face to face how to do that. And so and for example, for this cooperation, not only this webinar, we also will organize some kind of international meeting together, work together, and to provide some such kind of solution for the Sri Lanka, because I think for Sri Lanka, industry development will play more and more important role in the future development for Sri Lanka. So at this moment, so I do lots of research and cooperation with Sri Lanka since 2013, so nearly 10 years. And this year is also the 10th anniversary of One Belt and One Road initiative. So, and I think there will be lots of celebration and activities and the events for this the 10 years 10th anniversary celebration. So we can plan some kind of activities and also joint research and education and meeting such kind of thing together. So, and this morning, so we also had a very good meeting with our genetic administration at headquarters to discuss how to promote our cooperation with Sri Lanka and also other countries with the developed countries and the developed countries. So that is my brief introduction myself. So I hope I can meet you all in Beijing and all in your country in Sri Lanka in Singapore. That's all. Thanks. Yeah.
Thank you, Professor Wei, for a very nice introduction and a lot of common interests just now you show, in your talk. So I will continue to introduce our panel members, and we have Mr. Ishanka. He's our speaker, so we have him with us. And we also have Dr. Veragada from JRDC, and he's also with us. Okay, and okay, so I think Dr. Veragada, would you like to briefly introduce yourself as well, if you wish?
So, thank you, Professor Hu. So, Professor Hu is not new to me. We had a APN project in 2011 and 12, and wherever that we introduced the water safety plan to Sri Lanka for the first time. And Sri Lanka now doing very well in the water safety plan, and all the way WHO is appreciating us. So with that note, I would like to introduce myself as a water safety plan master trainer trained by WHO and an auditor recognized by WHO in the South Asia region. In addition to that, I am working as the director covering up for the China-Sri Lanka Joint Research and Demonstration Center for Water Technology. This is the recent established institute in the country to take up the research technology development in water and wastewater treatment. Thank you, Professor Hu. Thank you very much.
Thank you, Dr. Verigoda. And now I move on to introduce our last two panel members. They are from the same organization. I think first one is Mr. Ashanka. He's a Senior Deputy Director of Environment Management Board of Investment Sri Lanka. And together with him, his colleagues, Mr. Shishanka, Assistant Director of Environment, Central General Office, Board of Investment Sri Lanka. So I like to welcome both of them, and also like to invite them to say a few words about themselves. So probably Mr. Ashanka first, and followed by Mr. Shishanka.
Thank you, Professor. Again, good afternoon. So I'm Asanka Velagadara, currently working as a Senior Deputy Director for the Board of Investment Sri Lanka. Just give some brief introduction about the board, our role in the environment sector. So we have around 1,600 BOR registered industries, including the 14 industrial zone. Our main functions are to closely monitoring their environment-related activities such as pollution controls, emissions control, like that. So we operate 3 industrial monitoring laboratories in Katunayaka, Biyagama, and Horana. We do the environmental wastewater, water quality, and some industrial inside industrial monitoring activities like noise, dust, lux level monitoring also. So Just regarding the challenges we are currently facing is around waste sludge disposal mechanism. So as Professor Shaman mentioned that we don't have enough mechanism for the disposal of wastewater treatment plant sludge. So with that, I invite the Mr. Chintaga to introduce.
Thank you, Mr. Ashanka. Then Mr. Chintanka.
Okay, thank you so much for JRDC team and Professor Shamin, Dr. Veeragad, and all of you for inviting us to participate this comprehensive event. So we are working with JRDC from last year, I think. We are closely working with them to improve our environment prospect in the BOI. So as Mr. Asanka said about this explanation, currently we are facing some difficulties to manage wastewater sludge generated from the centralized treatment plant and the individual treatment plant. So in the BUI, we have 15 industry export processing zones in the country, and two are under construction. Within the out of 15 export processing zones, 11, nearly almost nearly 90%. 11 in the export processing zones belongs their centralized treatment system, and they are, as Professor Shamin explained in his explanation, pre-treatment. First, he should conduct pre-treatment and discharge into the centralized treatment system, and other 3 or 4 export processing zones have not their own centralized treatment system, so they want to treat individually with their enterprises. So we need some expertise and skilled people to handle that wastewater treatment system, and we need to improve their skills to manage it up to the satisfaction level, because we are catering for the export-oriented enterprises, and we are catering with the foreign buyers, and they always request for their requirement always meet the international standards. So we initiated green concept, green in the zone, and convert our industrial park and export processing zone into the eco-industrial park. So previous year we have some discussion with JRDC to collaborate with us to implement that plan. And currently we are linking with the NDC, Nationally Determined Contribution, that initiated by UNFCCC. So we act as a focal point to conduct this NDC program in our country, because BOI has a challengeable capability to work in even under any environment, because last previous year we we have some terrorist attack and some COVID pandemic. Even though we are as a BOI enterprises, we are working very strongly without falling our capacity. So UNFCCC selected BOI as a focal point to implement that program in Sri Lanka. Currently, we are engaging with NDC under 5 subsects like continue fuel switch into sustainable biomass, and convert industrial park eco-industrial zone, and circular adaptation with circular economy and tri-generation facilities, GHG reduction of clinker production. Mainly that 5 or 6 point we approach at the moment. So I think this session also we can link with our NDC program according to the wastewater category. But not only wastewater, we invite you all to collaborate with BOI in terms of the air emission, soil, fauna, flora, socials, and environment, all aspects. So I would once again I would like to thanks for the invite us to participate this program. Also, Mr. Asanka, I think he's our head of the department now. He has nearly 1,600 export-oriented enterprises under his hand. So yesterday I invited him to join with us. Even with the simple invitation, he also joined with us for the positive perception. So I thanks Mr. Asanka to participate this meeting and link with our JRDC team, you and all our experts. So thank you so much.
Thank you, Mr. Chinsaka. Very nice, summary about your people's work and your expectation in the future in terms of how to handle industrial wastewater in your industrial park. So okay, now we are moving to this panel discussion and the Q&A session, and we are going to have some questions. And dear participants, please do feel free to send your questions, type your questions in the Q&A boxes, and we are going to pick it up from there. And we have already gotten the first question, so I'm going to read about this question. And then the question is for Professor Olivia. Professor Olivia, the question, there are two questions for you. Okay. The first one, what are the main challenges associated with industrial wastewater reclamation? This is the first one. And the second one, do local people in Singapore accept new water for drinking purposes? So would you like talk a little bit for these two questions? One is about industrial wastewater reclamation, another is about the new water.
Sure, I can do that. What are the main challenges associated with industrial wastewater reclamation? Well, the one that I presented, if we're talking from a technological view, I think that the main challenge, actually the one that I'm most interested in, is the challenge of the process water, which sometimes can be very hard to treat. So I think that's why we have to develop all those technologies, because it's not very easy to substitute to put a normal conventional wastewater treatment plant. So I think that's the technological challenge. I think then there are also probably logistic challenges, because a lot of industries, they need to have their own plants. And then sometimes, be it even when you can have a biological plant, not everyone is able to operate a biological plant easily, especially when your wastewater, sometimes depending on the process that you're doing, will keep changing over time. So I think it can become a challenge to be able to adjust the parameters and to be able to make it work at all times. So it requires some expertise. Yeah, so for the first point, there is a need for new technologies. For the second point, it's a need for training, a need for knowing how to handle all of these obstacles and training. And I think for the second questions about the acceptation of new water, well, I'm not a sociologist, so I haven't made studies on the acceptability of new water. So I think that the only thing that I can say is that, first of all, for drinking purposes, new water, I showed you some examples that sometimes PUB likes to bottle it, or even that we have the beer that is made of new water. So I believe that when there is the bottled water is not sold, but the beer is certainly sold, and it's actually not cheap. So I believe that if people are willing to make a beer, advertise it and brand it as a beer that is made of new water, and they sell it, I believe there is a business for it. So I think that they must be making money, otherwise they wouldn't be selling it, or they would hide it. So I would say that most likely I would think that people are ready to accept it, at least some people. And then generally speaking, everybody is drinking some new water in a way, because tap water, some of the new water, so this talk wasn't about new water, but when you look at new water, most of it is used for industries, because a lot of industries, they require ultra pure water, and new water is actually purer than tap water, so because it's demineralized. So so most of the new water is not used for drinking water, but sometimes in times of droughts, some new water may be injected in the reservoirs in order to maintain the level. And so in this case, since the reservoirs are used to make drinking water, then it's a form of indirect potable reuse. So people accept it, but in a sense, how much people know, how much people, I'm not even sure that people know that there is some new water in that water that they drink, but that is being highly purified. So I believe at least there is no opposition, that's for sure, because in other parts of the world, there have been projects of water reuse that have been either very difficult to put in place or that have faced some hostility or in some places have had to be abandoned. And of course, the political systems in those countries are different than the political system in Singapore, but that's another question. So I think it's accepted. At least it's not being opposed. I think it's part. I think there is a good education. I think there is a positive discourse, as what I said, and some people are willing to buy beer that is made of new water and are willing to pay a premium for it. So yeah, I would say yes, but I don't have any scientific evidence apart from incidental things that I see. Yeah, I don't know if Jan Yong, do you have anything on this? Maybe you would have something. You can also answer this, I think, maybe.
Thank you, Olivia. And yeah, of course, I can add on something about the new water. And as Olivia said, it's an indirect potable reuse in Singapore. And people accepted it because we have very good public education, and there's a very stringent quality checking on the production of the new water process. So this is a quite established process in terms of indirect potable reuse, and quite a number of the countries actually in the world actually are practicing in this way. So that's why it's well accepted here, in terms of new water for this indirect potable reuse. If you are interested in this, I can have another separate lecture on that, because NUS team actually work on this since 1998. That was like 20-something years back, and we heavily work on this, and together with our government agencies. So we have done a lot of background work before Singapore start to launch the first new water full-scale plant in 2004. So yeah, but to be very brief, I think that's the answer. And I'd like to thank my colleagues Olivia just now for mentioning about the new water, and even new beer, this a beer, so I think that's something new, since last year, I think. Okay, so we move on to the next question. Next question is from Wasana. Okay, Wasana is asking, I think this question is towards our Sri Lankan speakers. So what are the membrane technologies that can be used for industrial wastewater treatment in Sri Lanka? And what are the methods for industrial sludge management? So there are two questions, and we will see who would like to address these two questions. Shamin, Professor Shamin, would you like to say something?
Yeah, I could start. Professor Wei would be the best person to answer on these membrane technologies. So when it comes to the industrial sludge management, I hope Mr. Asanka and Chintak would elaborate more after me. So currently we have, as I mentioned, very much limited facilities that we need to have kind of incineration. So we have to send for the who are operating under the company called INSI in Sri Lanka. So all the companies, they have to send this the kind of, when it generate as hazardous type sludge, you cannot dispose it, so that it has to be sent to them. So that industries, they are facing the cost wise and also the operational wise both. so that we have to see how we can reduce the amount of sludge that generated from these industries. What are the possible ways that we can accommodate to reduce the generation of the sludge, and also what are the possibilities of converting the sludge for example, some of the team that we have worked. Can you hear now?
Yeah, you are back. That's very good.
So
Please continue.
yeah, so that from with the industry, that some of the industries we have worked with, so whether the sludge can be used for convert them into usable products like construction purpose, or like animal feed, or some other reuse this kind of oil and stuff for some purpose. So same time, we need some kind of methods, especially the R&D, to manage how the industry specific sludge to operate it. So that's the kind of regarding the sludge. And when it comes to the membrane, actually Sri Lanka, it has been implemented, but still there's a big room for us to expand this, for especially the expanding the current treatment plants, as I mentioned, like even the anaerobic systems, where we can convert them into the anaerobic MBR. So where rather than we are having expanding in the size, and also like later on we may need to have the membranes to be developed in our country itself, so that whether we can have our all the products in our system. Like otherwise, when you have to replace, or the like similar to the pumps and other items, even the membranes, we have to depend on like other countries. So we need to develop all the technologies in our own system. So that's the kind of with just a basic understanding. Maybe Mr. Asanka would elaborate a little more. I will ask Professor Day also to after that to elaborate a little.
Thank you.
Yes.
Yeah. So anybody want to add on? Is that Mr. Shankar? Asanka?
Yes, regarding the membrane technology, normally in Sri Lanka we use some RO, reverse osmotic treatment system, but only problem is how we can manage the reject of treatment, treated water. With containing the high TDS and other high concentrated chemicals. So only two options available. If we can go for the evaporations as a zero discharge method, or can discharge through the CO bowl. But due to the standards, so we cannot recommend to the discharge the water to the CO bowl. So the other thing is that other problem is when we go for the evaporation options, we going to face the energy issues and the cost encouraged to that kind of operations. And other thing I want to point out, the industrial sludge management. Normally we, as Professor Shaman said, that we send to the disposal to the INSEE. But nowadays we are initiated our discussion with the UDA to convert their sanitary landfill and Arwakar for the at least one. We have tried to obtain the one cell for the industrial sludge disposal. Due to that geological and then other groundwater conditions in that Arwakar area, we can easily implement, because there's no chances to contaminate with this leachate with the groundwater. And also we are practicing some for industrial specific options like pumic stone sludge. We do that making the pumic stone sludge to make cement block. So that accepted by the Central Environment Authority with regard to the TCLP and other tested parameters. So like that, we are doing some other rubber industries also. I think it's not better to mention their industry name. They use their waste rubber sludge for using the paving stone for the for road construction also. Like that, we have some industrial specific options also. But thing is, we have to many area to develop to how to effective to use of the industrial such management, and also we have to consider the cost factor is a main things, because actually as a BOI and we are facing we are challenged with this other countries like India, Bangladesh, Vietnam also. The main issue is our final cost of our product. So if it's high, if cost for the industrial waste management, the final product cost also will high. So then it's not feasible for them to adapt this kind of technology. So when we find the solutions for the industrial waste management, first thing is we have to identify the sustainable way as well as the financial factor also.
Thank you, Mr. Asanka, and the very nice, answers and, to address quite a number of the issues associated with industrial wastewater management. And one thing just now you mentioned, which is associated with membrane technology, you mentioned about RO, but by using RO, you generate RO concentrate, and you also talk about those pollutants in the RO concentrates are rather difficult to deal with. So that's another, group of the another type of the waste. It's kind of also industrial waste, and we also need to handle. And advanced oxidation process, like ozonation and Fenton process actually can be utilized in that particular situation if you're really concerned about the RO concentrate and also the pollutants inside that RO concentrates. We have done some work in this field, and that's why we start to look into this kind of waste stream. So it could be important aspects in terms of industrial wastewater management. So I fully agree with you. We should look into all of those potential pollutions. Okay, so let's move on to look at the question come from Gana Haran. And the question is about how to continue monitoring and improving these treatments are functioning and maintaining as required standard in Sri Lanka. So maybe this is more relevant to someone who's doing the real plant operation. So let's see who like to actually take up this question.
Ms. Chintak and Dr. Veeraguda both, I think, could.
So yes, first of all, so let me start. So Sri Lanka, there are we have the Central Environmental Authority. So Central Environmental Authority we call CEA, like the US EPA. So Central Environment Authority is the entity which is holding the right to go and approach, monitor the industries, especially the waste generation part. So they have the industrial license. So then the industrial license is that we call EPL is issued by the Central Environment Authority. So as per their mandate, they have to visit 3 times the industry, and they have to make sure whether the industries are adhering the industrial waste discharging standards. As we know, all for the different industries, we have gazetted different standards, like for the rubber industry, like for the textile industry and general industries. So that is the guideline. So when you're having any sort of new upcoming industry, so CEA is responsible to go for the environmental impact assessment or initial environmental examination to authorize them to go for further establishment. That is for the general context in the country other than the BOI. I think Mr. Asanka can elaborate us how that the BOI is handling this, because there are some relaxation for BOI premises.
Yes, I think Chintak also at some point after me. For the environment monitoring and for EPA. As a BOI Act, BOI is the responsible agency for issuing the environment protection license for the BOI registration, BOI registered industry. So normally in our zones, for example, to take Katunayaka, we have around 83 industries, and we have the central wastewater treatment plant. For the wastewater generating industry, they have to treat their wastewater up to the BOI pre-treatment limit, quite a relaxed limit for them, and then they have to discharge our central wastewater treatment plant. Then it's responsible go to the BOI. BOI have to take care of this pre-treated wastewater, treat up to the CA standard. Normally the CA has allow us to do our treatment, wastewater treatment up to the inland surface water quality standard. There are the 3 main standards published by the Central Environment Authority as inland surface water quality standard, and industry can treat up to the agriculture purpose, and there are several separating standard as well as the sea outfall standard. So normally BOI in the Katunayaka, we do the environment monitoring in once a week in our central wastewater treatment plant, as well as the once a month in our industry. So we collect the wastewater treatment, treated wastewater sample, and in our own laboratory we do the environment monitoring, wastewater quality analysis. So other than in addition to that, as per the EPL regulations for our export processing zone, CA monitoring 3 times per year for our wastewater quality standard from the central wastewater treatment plant. In addition, outside the zones, we have around 800 industries, but I cannot exactly say the number of what are the wastewater generating industries, but normally they have to obtain the treated wastewater quality report from the CA recognized laboratory, and they have to submit us to the in order to consider for the renewal of their EPL. For normally they do the 4 times per year. So Chintaka, are there any missing part from me?
Yeah, may I add something about the candy and some export processing zone which has no centralized treatment system? Because when we consider about the candy that's near to the JRDC, our area is demarcated as a sensitive area because that closely for the water intake. So we have no right to install a centralized treatment system. So as a BI, we recommended all enterprises to manage their own wastewater, solid waste, and with their own effort. So they use an individual treatment system at their premises. Then we recommended them to reuse the whole wastewater treatment system, wastewater, treated wastewater without discharge into the outside inland surface. So they are trying to treat it up to the national standard for the inland surface and reuse the all wastewater generated due to industrial activity. So I can share some slide regarding the reuse of wastewater.
Yes, please go ahead and share.
Yeah. This is some cultivation in our Kandy industrial zone. This is all cultivation done using the treated wastewater up to the inland surface. In terms of the monitoring system, we recommend them to obtain a wastewater treatment and wastewater analysis report from the government registered institute in quarterly. But it is up to our recommendation. We monitor that industries we can assign them to obtain a wastewater analysis report monthly or quarterly, once in 6 months, something like this. So they should obtain one report from Central Environment Authority, and others can obtain from CA Central Environment Authority registered laboratory. So we are focusing with the JRDC to take part with our BUI to provide laboratory facilitation, because our enterprises suffering from lab partners. Currently, they are facing some difficulties with the current crisis and providing transport facilities to laboratory. So monitoring mainly divided into two parts: physically and analysis method. Physically, they are using some odor and sludge, color of sludge. So we appoint a skilled person to handle that wastewater treatment system. In addition, they should, as I told earlier, they should obtain laboratory service from CA registered or CA laboratories. So that's the background in a Kandy Industrial Park.
Okay, thank you, Mr. Chintaka and also Mr. Asaka. So we now actually have one more question, actually very specific to your BOI. And I don't know whether just now you have already touched on, probably you have already touched on some points. Okay, basically the question is from Charu. And the question is, first of all, what are the steps taken by BOI recently? What are the future plans for industrial waste management? And what are the challenges faced by BOI in managing industrial wastewater? And what are the R&D options? So I think I would like to again turn to Mr. Asanka and Mr. Chitaka and see whether you think there's something else you'd like to address.
Yes, as I mentioned earlier, industrial waste management is a big challenge for us. But nowadays we are calling that UI for some interest party for to install the incinerator for our three major zones in the Katunayaka, Biyagam, and Sitauka. Is the one thing now we are considering. And other thing is, I also mentioned earlier that convert the Aruwakaru Sanitary Landfill as a industrial waste management center. Those are the two things. With regard to the other thing is that non-hazardous waste, industrial waste like biological treatment plant waste, we got the approval from the Agriculture Ministry and Central Environment Authority for the converting as a soil conditioner and as well as making as a compost fertilizer. So those are the things with regard to the industrial waste management. And other thing is what are the challenges in the industrial wastewater. Actually, we have enough technology for BUI as well as the industry. Most of the industry, they taken their new technology from their origin countries like the German or US or Japan. But thing is, our people behavior of some peoples. So they just consider about this financial factor, and we face a lot of challenges in our zones also. They just discharge unauthorized discharge. This is the main challenges considering the overall process of the wastewater management. Other than that, we don't have any issues with regarding that industrial wastewater management, but and also for that the unauthorized waste water discharge, we are now going to install the online wastewater quality monitoring system for our central wastewater treatment plant, and then we can monitor online whenever we can access to the mobile phone or that internet facility. We could such kind of new technology we are going to install. So then research and development, of course, we have a lot of research area, problematic area to find solutions like sludge management. basically how rather go for the incineration that's also contributing the CO2 emissions, but not for the incineration. We if we can go for other use as a another solutions, like some industries use that what you call that for the rubber gloves manufacturing industry, they use their rubber waste to the another different kind of byproduct. So like that, we can develop some byproducts by using that waste. Also, then that also some mineral requiring from the some plants. So there are a lot of research. The problem we have to develop the solution. So always be encouraged to the universities and other professional bodies to come with us and join with us to develop that sustainable solutions for the industries. So always BY is open for the new proposals and research works.
Thank you, Mr. Asanka. Very nice, answer to just now, the R&D options and your future development. I do agree with you, like sensing and digitalization is a way to go, and it will help you to equip your wastewater treatment plant in a much better way, and so that you can control those illegal discharge in the real time, right? So anything to add on?
Professor Zhang Yonghu. So maybe I see there's some question related to me, so I can answer some questions.
Yes, please. Yeah.
Sorry. So I just see this. Yeah, sorry. For the membrane technology can be used for the industrial wastewater treatment in Sri Lanka, I think. And for this one, based on our experience in China, so generally there's the first. The industrial wastewater treatment should meet the requirement, discharge requirement. So this is the first. So depends on the discharge requirement. So there is often used the membrane bioreactor to treat industrial wastewater. So that would be for this one. Generally, and in China, there are lots of standards for industrial wastewater, different kind of industry. So there's two kinds of discharge standards. One is indirect discharge standard. So it can meet the requirement for the sewer system. So there's two barriers, three barriers. One for the factory, then the industrial wastewater in the park, then the municipal wastewater. There are three barriers. So for the indirect discharge standard, so they can meet the sewer system, discharge into the sewer system, the standard. Generally, that will be this is not one strict, like the COD roughly 500 milligrams per liter. So that is okay. So this one they generally use the conventional process. That is okay. But the other they need to meet the requirement for the direct discharge. This is very strict. For example, maybe COD is less than 100 milligrams per liter. So this one maybe lots of industrial water cannot use the conventional technology. It cannot meet this such kind of requirement. There may be the need for the need some membrane technology like the membrane bioreactor. Okay, this one thing. Okay, and another also know in the Eastern China. So because Eastern China, there the population density is very high, and there are also lots of the water network. So the discharge standard is very high. So maybe they need to reclaim, reuse the wastewater. So maybe membrane bioreactor is not enough. You need advanced technology, like the advanced the oxidation technology and RO and the nanofiltration, such kind of membrane technology. So all the membrane technology used, it depends on the standard, discharge standard and the reuse standard. So I think for Sri Lanka, so that is the same. So as I know, Sri Lanka wastewater treatment standard is not so strict. It's not so strict. So, but for industrial wastewater, you need to set up a discharge standard to meet the requirement to match the local development. Okay, the second question is for the industrial sludge management. That is generally in China, based on our experience, there should be based on the toxic the substance like the heavy metals and organic pollutants. Depend on this. If this sludge, if your sludge is considered as the toxic substance inside, it should be well strict. It should be treated by the toxic and hazardous the solid waste. There's special treatment. There's special institution and organization to treat that. And for the normal sewage sludge, that is similar to the municipal wastewater treatment plant. The sewage sludge, that is okay. You can do it like incineration and also landfill and the anaerobic digestion composting, something like that. So it depends on the substance, and this also need to set up the standard. So, and I think this moment for Sri Lanka, because for my opinion, maybe the first you need to set up such kind of discharge standard for your wastewater treatment discharge and your sludge treatment and disposal. You can select. If you cannot do that, you can set up a general standard. In China, we also in 1996 we announced a general discharge standard for all kind of industrial wastewater and sludge. Okay, this will be general, and then when you are economy development, technology development, then you can, based on the technology requirement, you can make a special discharge standard for the special industrial wastewater. So there are lots of the standards for the different kinds of discharge standards, because to protect the environment is the key for the industry and the industrial park. That is our China's experience. I would like to share for this. So, but I think any kind of standard should match your country and the local the development. If too strict, maybe it will be not so good, and too loose is also not so good. It should be balance. Okay, that is my answer. Thanks. Yeah.
Thank you, Professor Wei. Thanks very much for sharing with us your experience, especially how to set up the standard and manage the industrial wastewater in China, and also you give some suggestion, how to do that in other countries like Sri Lanka. So it will be very valuable. Okay, so I guess we don't have any other questions now in the Q&A box, and we come to the end of this panel discussion. I would like to thank all our panel members. Right, we actually now is going to end our panel discussion, and then subsequently, what I'm going to do, I move on to the closing remarks for today's webinar. Okay, so this afternoon we are very glad to have such a webinar, and the webinar gathers information from China, Sri Lanka, and Singapore, and this webinar provided knowledge sharing platform to enable appropriate collection, treatment, disposal of contaminants of concern in the industrial wastewater and enable sustainable industrial operation and management. Nowadays, water in industry tends to form a recycling loop. This is because of regional water scarcity and strict policies on emission control and rising public concerns as well. So this kind of trend would bring about the challenges for technical solutions and management tools, which include the standard just now Professor Wei emphasized. So our today's webinar especially also has shared challenges, technology solutions, as well as the new advances related to the water recycling in the industry in both Singapore as well as Sri Lanka. So the following technologies and the management tools are identified in our webinar and together with our panel discussion with a focus on appropriate and sustainable water treatment systems for industrial wastewaters to enable safe discharge to sewage system or to the water environment. Okay, technologies will include, for example, advanced oxidation processes, such as ozone, UV, and electrochemical process, and absorption processes, membrane processes, biological processes. And we also observe some very interesting trend, which include sustainable treatment through a robust economic approach, which is emphasized by Professor Charmaine because the cost is a very important deciding factor, right? And we also talk about something very, very interesting, such as digitalization and resource recovery, which is also covered by our three speaker speeches. So Singapore and the Sri Lanka's experiences in handling the industrial wastewater, which are shared in this webinar, are very valuable to water industry for achieving circular economy growth in the new era. So the information in this webinar will be the basis for the both countries' effort in terms of industrial wastewater management control in the coming years. All right, so with that, I'd like to thank to all the invited speakers and panel members and also organizer from NUS NERI and NUS Center for Water Research, the China Sri Lanka Joint Research Demonstration Center for Water Technology, Ministry of Water Supply, as well as BOI, and for your contribution, for your effort, and thanks to all the participants for your questions, your inputs, your comments, and your interest. So see you in our next event. Here I make announcement, which is 1 week later, 24th February afternoon, we're going to have a CWR seminar, which is about advanced technologies for emerging pollutants removal in water. And this event is a physical event, so it's going to be in our Temasek Lab Building Level 5 seminar room at 3 p.m. So it's more for local, but for our Sri Lanka, participants, I think if you are interested, we can actually think about subsequently some of the online sessions. So eventually this webinar will finally end. I'd like to thank all of you, and I'd like to also get back to Zamil, right, to see whether you have the final words to our participants. Thank you. Zamil, hand over to you.
Yeah, thank you. So I believe it was a fruitful discussion and it was a successful webinar for us. And in this series of webinar, we have went on with water and water treatment and management, wastewater, and so on. So I believe that it was a fruitful discussion for us, and especially the Q&A session. We had expertise from China, University of JRDC, and we had participants from Board of Investment, BOI, Sri Lanka. So thank you so much. We are winding up the session. Thank you.